Alright, so today what we are learning is we are going to learn how to convert rates. Now we did a very, very minimal of this last week. Remember when we talked about how many like feet, inches, and how many meters and a centimeter or centimeters and meter type thing? That's basically what this is all about. Except for the fact that those you guys should have been able to do because you already know how many inches are in a foot. You already know how many centimeters are in a meter. Those are kind of the easier ones because those are standard to standard or metric to metric. What we're going to work on today is we're going to be going from standard form, or I call it standard, I don't know. Yeah, it's the US form to the metric form. Okay? And back. So, first thing we kind of talk about is that dimensional analysis. What part sounds complicated?
Dimensional analysis.
The word also no.
Well, I'm not going to argue with that point. It does sound complicated.
It sounds like Dr. Science.
What dimensional is used in science? Please don't make me have to shout above you. Okay? What a dimensional analysis is, it is a process. It's a process of including units of measurements as factors when you compute. Now, remember, ever since we started this chapter, I've been telling you those labels are going to be very, very, very important, haven't I? I use them for setting up. They are going to basically, using the labels and putting them in the correct spots is what's going to make or break you in this lesson. Meaning either you will know how to do this, you'll be able to solve these problems because you're using it correctly, or you're not using labels, or you're not putting them in the correct spots, whatever it is, and you will completely fail it. There is a big struggle on that. So you've got to pay attention to the labels on this. Okay? We're going to start with something a little bit easier. I'm not saying it's easy. It's one of the easier problems we can do because it's something you guys do know how to convert. Okay? We are going to convert 100 miles per hour and change it into a label that has miles per minute. So here's what I want you guys to do. I want you guys to pull out basically many different colored highlighters as you are going through, as you have, because, and I can't give you a definite amount of this, sometimes you'll need 2. Sometimes you'll need 3 or more. So just get several different colors if you can.
Why do you like clothes?
Okay, 3, 2, 1. That doesn't mean we need to get loud, guys. Now, I'm going to show you how to do it. Remember, I told you the very first thing I do to set up ratios, to set up unit rates, to set up any of those, we base it off of the labels, right? So I'm going to, each label has a different color. I don't even care what colors. I have, starting off, miles. I use yellow. It doesn't matter. Just, you're going to have to color code what you have. Per hour, right? If I want it miles per hour, which one goes in the numerator? Miles. So I'm going to start off with miles over hours. Okay, and I can fill in that rate just fine. It is 100 miles in 1 hour. That's what it means by miles per hour. There's only 1 hour. Now, I'm going to actually kind of skip a section. Well, hold on. It kind of depends on how you want to do this. This one's only going to need one more fraction in between. Some of the problems we do is going to mean like 2 and 3 in the problem. Okay? So I'm trying to decide how best to do. I do it one way, Miss Vincent does it another way. She likes her way, I like my way, but we both agree each other is good, so sometimes I kind of mix it up. Does that make sense? Okay, there's several different ways to solve. I'm trying to decide which way is best for you guys.
Do both.
I don't want to do both right now, because if I do both, that will confuse. I'm trying to decide which one will best work for the whole class. I'll do it that way, and then when somebody gets stuck and needs it a different way, I'll go talk to them individually. All right, so here's what I'm going to do. Our next set of labels, it is miles per minute, right? So I'm going to, miles stays in the same color, but I can't highlight minutes in blue. Why not?
Because it's minutes, not hours.
Because it's minutes, not hours. Minutes are not the same as an hour. In fact, if that was, then you guys would be spending like 62 hours in here. No, that's not gonna work. So that becomes a different color. Okay? Here's the reason I do this. How many of our labels actually change? One, and just one. So I'm going to, everything we do today, it's all going to be a whole lot of multiplying. Since only one label has changed, I only need one fraction right here, and it's going to equal, well, actually, it's not a fraction, I should call it a rate, I'm sorry, equals another rate. Now, here's why I'm doing this. Which one changed?
The hour.
The hours. So our miles gets to stay the same at the very end. Do not do anything to this middle yet. It's not going to be the same. It is very relevant. It is the one that's going to make or break you. This one changes colors. Because we have miles per minute. Okay, I'm going to take a time. Yes, you can abbreviate. I'm going to take a time out. I am not even close to done. I don't want you thinking about what comes next. I want you thinking about just what I've written out right now. Are we okay with what I've written out right now? Okay, anyone who says kinda, I'm not upset with that, I'm just making sure. Kinda, is it because you're okay, but you're really confused as to where I'm going with it?
Yeah.
Okay,
Perhaps.
but right now, we're okay with what we have.
Yes.
All right, now here's the thing. Each color we have used has to be used twice. Have we used the yellow twice in here?
Yes.
We're gonna put the yellow away, we're not using it again. Have we used the blue twice?
No.
We need our blue out, or your, whatever you're using in place of blue, I don't care. What about this one?
We need to keep it.
You need to keep those two out. Okay, now here is what it is. You want, whatever is changing has to change places. So what did we start with? Hours, right? Hours has to change places because hours is in the denominator of that fraction rate thing. We are going to move it up to the numerator. Okay? Because minutes is what we want to end with in the denominator. We want to have it in the denominator right now. I will explain that one in just a minute. Well, actually, I'll do it right now. We have this hour, right? We have minutes. You know how we can cross reduce a lot?
Yeah.
You can do that with labels. Is miles the same as hours? Is hours the same as minutes?
Yeah.
Hours is the exact same as minutes,
No.
so instead of being in my classroom for 62 minutes, you're gonna be in here for 62 hours?
I wanna be here for 52 hours.
Exactly, so it measures the same thing, it both measures times, I agree with that. But is hours the same as minutes?
No.
No. So none of these can cancel out top to bottom. Is minutes the same, miles and minutes the same? Is hours and hours the same?
Yes.
We're going to cancel those out. Just the label, no numbers, it is just about that labeling. If you have an hour in the numerator and an hour in the denominator, can you cancel them out?
Yeah.
Yes. Now look what labels are left right here. Isn't that what we want at the end?
Yes.
That's why we do it. The one thing we are missing right now, what do we know about hours and minutes? Which one's bigger? So in 1 hour, how many minutes are there? 1 hour is equal to 60 minutes. This isn't really saying a fraction, it's saying 1 hour is equal to 60. Pause right here. Are there any questions? Or what questions do we have? Because I'm sure somebody must have one. Don't be afraid to ask, Gage.
So, you just put miles over minutes?
Wait, for labeling, yes. We're not done yet. Any other questions
I'm
right here?
confused with the labeling and then the numbers. I'm confused. Like, how do you know it's there?
I'll be getting miles over minute at the end.
Okay, I gotta ask like 2 and 3 different questions. I'm trying to think of how best to explain it. All right, so let's say I didn't cross off those hours yet. All right, they're not crossed off. Let's go ahead and just multiply out. I'm going to have to write this below because I obviously don't have space. What is 100 times 1?
100.
100. That everyone gets, right?
Yeah.
But it has to have the labels. If we did not cross reduce those labels, we would have 100 miles, hours, right?
Yeah, that doesn't make sense.
I don't. Final answer, it would not make any sense. I am doing this so that way you can see why those labels cancel each other out.
Okay.
Right now, if I did not cross off the hours, it is 100 miles hours. Yeah, makes no sense whatsoever. I agree.
100.
The denominator, what's 1 times 60? 60, and it would have been hour a minute, right? Okay, I'm going to do one thing. All I'm going to do is rearrange my labels. That is equal to 100 over 100 miles hours over 60 minutes hours. The only reason I did that, what if this had been A over A or H over H? They cancel out. These two right here, since they are identical, they cancel each other out. What's our answer?
600 miles.
Oh, so it's basically.
It is the exact same thing. I'm just trying to show you the short way of doing it. One last thing we have to do here.
Do I have to write it down? Because then I would be more confused.
If this part writing it down is going to confuse you more, then don't write it down. Okay? We have 100 miles over 60 minutes, but I don't like that. Simplify by what?
10 times.
No.
6.
What were we doing last week on Friday? What did we simplify by?
The
Oh, wait, let's turn back in the notes.
Oh, I put 26.
Actually, I'm sorry, it was last Thursday. What did we say? It's a rate. We're not fractions, we're rates right now. Always divide by the denominator. The hardest thing we're going to run into right now is knowing, is this a fraction or is it a rate? Is this a fraction or a rate?
Rate.
It's a rate.
Because it has labels.
There you go. Perfect.
I thought you were going to say 1.
Perfect. It is a rate because you're comparing two different things. Okay? And because it is a rate, what do we divide each one by? So 100 miles over 60 minutes, we're going to divide them both by 60. And yes, you catch this. I don't want to do that in my head either.
1.6 repeating.
Or 1.7 with rounding miles or 1 minute. Okay? 1.7 if we're rounding, which we tend to round. I don't know why we have to do repeating decimals, since from now on we tend to round them. So 2 minutes? With the rounding? Okay, I get that. How many of us, even if it's just the smallest thing, how many of us are still confused? Okay, because like
Okay.
every year somebody's confused, so don't tell me this, because then in like 2 problems you'll be sitting here going, Miss, I don't get it. Okay, let's go to the student page, just for space to work.
I have a lot of things. Yeah. Surprising. I told my mom.
All right, so let's try that same process. First thing I want you to do, what is the starting rate or ratio? The starting unit rate, the starting labels.
Per year? Money
What
per year?
Money per
There
year?
you go, money per year. So dollar amount per year. Okay, so if we write this as that rate in fraction form, what is the numerator?
The money.
The dollars. Money
Oh,
tends to be the numerator. You usually want to know how many dollars per something, not how many items per dollar. So it's dollars over what?
Year. Week?
Years. Just a starting. You just look at that starting one, okay?
I'm kind of behind.
All I'm doing is highlighting.
Okay then.
Okay.
Okay.
Oh, we are all okay with that?
Yeah, why not?
Easy enough? Okay. Then, next step is fill it in. Fill in your numbers.
When
What do we know about the dollar amount?
We have 1,000.
1,740.
In 1 year. Okay. Great, right? We've been working on that. That one's easy enough.
Yeah.
How many labels change?
1.
1, because what does it have to become?
Oh,
Dollars per week, right? Okay. That means we're going to multiply. You have 1 ratio, and it's going to equal this over here. One label change, you only need 1 in the middle. Okay? Everyone okay with it?
yeah.
What changes?
the denominator.
The denominator, 2 weeks. The dollar sign is just fine. We're not going to worry about that dollar sign at all. As soon as you start getting confused, tell me to stop. All right?
You can only use it twice?
Yep, so I only want you to use those colors twice, and it's going to be a very good way of
So like if you have 3 different, like if
that's going to be our next problem.
that's what.
It will be our next problem, I promise you. We will get there. Okay. So you use whatever color you're using. Do I need that yellow?
No.
No. So I need the other 2 colors.
Yeah.
Okay? The dollar sign has been used twice. We're not going to worry about that. So what goes in this middle one right here?
The years in the week?
The years and the weeks. Now, which one are we getting rid of?
Well, yeah.
Since we're getting rid of the years,
It's the number.
it changes spots. So it goes up the numerator. And don't just say it goes to the numerator, because there will be times where if that was, like the first one said convert miles per hour to miles per minute, it could have said convert miles per hour to kilometers per hour. Then it would have changed to the denominator. So that's why I tell you the
So
label moves.
So wherever it is, it just goes up.
It goes to its opposite spot. Yes. That is why I say the label moves. I don't tell where it moves to, I say the label moves. It goes to its opposite.
And then the week is at the top.
Mhm. So now we can fill that in as years, 2 weeks. Great, right? And I am trying to take this as slow as possible so you understand it, but as fast as possible so we don't waste too much time on it and you guys can't get everything done. Do we know which one's bigger, a year or a week?
Yeah.
Okay, so that gets the one. At least that's why I'm gonna put my one. Okay, how many weeks?
52.
52.
Now, we're gonna multiply across.
No, we can no.
What can we cross reduce?
The year.
Cross off the years. That was the whole point of putting those years, not because we wanted it, but because it helped us set up the problem. Now, huh? Only the years, not the numbers. Only the label. Because we want that one. We want to say, what is 1,740 times 1?
1,740.
What is 1 times 52?
52.
Now, yes, we could have continued to cross reduce right here because something could have gone into 52 and 1,740. Is it okay that we didn't? Yeah. Yes, because what can we do right now?
Multiply.
By what?
The denominator.
Well, that's a really long number.
Okay, so what do we get?
33, 46, 1, 5, 3, 8, 4, 6.
Okay, and it keeps going, keeps going, keeps going, right?
No, I didn't get that.
47.
33,
Oh, wait, I
4,
did.
6, 1, 5,
Yeah.
and it keeps going, right?
Yeah.
Here's one thing I want you to think about. Your labels. That's dollars per week, right? How many decimals show up in a dollar sign? 2. 2. Maximum of 2. So read the instructions. If it does not tell you to round, for dollar amounts, you have to round to the nearest hundred, whether it tells you to or not. Unless it tells you to round to the nearest 10. Okay? So what is it?
46 $46.
Per one. There you go. Yes.
Do we have to show this, because this can be like a little confusing, instead of just going, okay, there are 52 weeks and you were 1,740 of
Can you find your comment as to why? I agree with you. I mean, that would have been easier, just take it and divide, right?
Yeah.
So not always that nice. Where's it is? Here's one. This is why you guys need your book out. Here's why we do this, Gage. Because this also includes problems such as, I'm going back to my teacher page. This will also include problems such as 4 quarts, 2 liters. This one, I'm sorry, I really hope I'm not confusing you, that's just why I kind of slow down. It's a little bit different, it's exactly the same, but different at the exact same time, I mean, because it's not telling you courts per anything, right?
Yeah.
No. Exactly, it's not doing that, so do we have two labels? No? Do we have two labels for one fraction? No, this is quarts and you want to change it to liters. It is not two. So what you do is you put 4 quarts over 1. Gauge, this is why I want to see this down, because I need to see that you guys are doing it correctly. Times something to equal liters, basically.
Liters over what?
4 times that.
Huh? To be.
Well, actually, it'll be over nothing. It'll be over nothing. We don't have a label for it. All right. I want you guys in your books to turn to page 201 quickly. 201.
Ms. Meyer, you need bandage.
What'd you just do?
He cut himself on his pencil. Well, damn it, stupid boy.
Who's Sergio? That's good.
Sergio, here you go. All right, guys, I've slowed it down way too much. Not you guys, it's me. I've slowed it down way too much. All right, so you guys on page 201?
Yes,
Yeah.
we are.
You see this key concept about the middle of the page?
Yes.
Measurement, conversion.
Yeah.
Quarts, that is the customary. There we go. I wasn't seeing it, but it was customary. I was trying to think of. Quarts is the customary. That's what we usually do. Liters is metric. We are converting from customary to metric. So you have to look on this page and figure out, since we want to change from quarts to liters, quarts is changing, right?
Yeah.
So our quarts moves. Our liters stay.
Is this what you mean by it's not always gonna be?
Yeah, it's not the setup. The idea of the setup is always going to stay the same. The way, like the numbers used, the label, that stuff changes constantly. So looking on this chart, quarts and liters, is that going to be measuring length, capacity, or mass? Capacity. So find in there where it's talking about quarts and liters.
I found it.
Okay, which one did you find though? There's 2 of them.
I got 0.946.
And if you go next to it, it's 1 liter equal, is approximately, because it's not equal, it's approximately 1 and 57,000 quarts, right?
Yes.
Here's the hint. Here's what I do. I want to get rid of my quarts, right?
Yeah.
I'm going to put a 1 right here. If I have that option, I want my 1 right there. Can you guys guess why?
Why? So you can get rid of it.
What's 1 times 1?
What?
1. Well, you need a denominator of 1?
No.
That's going to make it easier. So 1 quart is how many liters?
What?
1 quart is how many liters? You look on that book page.
946,940,000.
Okay. Our quarts cancel out. Now, Gage, the reason I want you guys writing it out is you have a great idea, I promise you. But a lot of students will start going with that, and then they'll get something like this and immediately try to divide. Because they're used to it. Is that what we wanted to do? We want to multiply. We want to multiply. So take those 2 numbers and multiply them.
It's that. It's 0.4644. I mean,
No, you're trying to add, multiply those 2. Take 4 times 0.946.
784.
Huh? Okay, I did not hear the thing.
3.784.
All over 1, right?
Yeah.
What is 3.784 divided by 1?
3.784.
4 quarts is approximately 3 and 784 hundredths of a liter.
That makes sense. Yeah, that makes sense.
Well, 4 quarts, that's a gallon, right? Take a liter of pop. How many liters of pop would you need to fill up a gallon jug? 3.784. That's how many liters you need.
That makes sense.
That's what, Camilla, that's exactly why. For us, for America, milk comes in a gallon. Do you think milk comes in a gallon in the United Kingdom?
No. It comes in kilometers.
It comes in liters. Kilometers is distance.
All
right. So I'm going back to the, oh wait, we're almost out of time. We will continue this tomorrow. You do have homework, but we will continue this lesson tomorrow. Huh? Yes, thank you for reminding me. I will as soon as I stop the video. How about that?